Welcome. This is a really good crowd. My name is Chris Morgan. I've been at Red Hat for 8 years. I'm currently responsible as a technical director for our OpenShift partner ecosystem. And I would personally like to thank the scheduling gods because I've been able to speak at every summit. This is the first time I'm not between you guys and happy hour. So I really appreciate the upgrade this year. It only took 8 years to earn this coveted spot. Thank you. So, the show of hands, just so, because Chuck and I kind of like to maybe tailor the presentation a bit. Who here is an admin, an ops guy? Okay, that's about 30%. Developers? Yes, my people. All right. So, and then business folks. All right, cool. So hopefully we'll kind of have something for everyone as we go through. We'll have time at the end for questions, but if something's just really burning and you just gotta just throw your hand up, we'll go ahead and try to address it as that happens. So before I let Chuck take over here, we're going to go through today some 101 because I realize not everyone may know what OpenShift is. In fact, how many of you thought this was just an OpenStack presentation? Right. So no, we are going to talk about OpenShift. We'll talk a little bit about OpenStack and how it works with OpenShift. But then, if you heard Paul's keynote today, hybrid cloud, as has been the case for several years with Red Hat now, is there. But why does it matter, right? We're going to talk a little bit about that. And then, we are going to go in, because I think we rated this as a kind of pseudo-technical session. We're going to go into some technical aspects that you want to consider when you're looking at OpenShift on a hybrid cloud. And then, we're going to turn it back over to Chuck, who's going to talk to actual customers and what they're doing in these environments and how they're doing it and the considerations they're making. And then again, we'll go into some Q&A. So with that, I'm actually going to just turn it over to Chuck.
Thanks, Chris.
He's going to roll in.
All right, my mic fell off. Can everybody hear me all right? Awesome. So my name is Chuck Swoboda. I am a cloud and middleware specialist for public sector on a certain team that works a lot of civilian accounts. And my background, software engineer by trade, so I can geek out with the best of them, although I'm a little bit further away from it now. But what I want to talk about first is actually, what is OpenShift and how it relates to DevOps. So I know DevOps is kind of a nebulous, kind of buzzwordy term. In fact, I think we'd probably have twice as many people in this room if I put DevOps in the title, along with Unikernel and maybe IoT, who knows. But when I talk to customers about what DevOps is, they get a lot of answers, and that's what's up here on screen. Things like developers and operators working more closely together, and developers deploying to production, moving faster. And I even had one customer tell me, developing in Node.js and Ruby and tight jeans in a Starbucks. I mean, that's what a lot of folks tell us what DevOps is, and they're like, we're not ready that. I'm not ready for my developers to wear tight jeans and deploy to production. And like, okay, well, that's not really what DevOps is. DevOps these are all symptoms of DevOps. And what I want everyone in this room to galvanize around and help me sell this idea, DevOps is the ideal of concentrating on business results rather than technical details. That's not to say you don't forget about the technical details, but what we want you to do is focus on business requirements. We want you to deliver real value. What are some of those technical details, though? This: operating systems, role-based access controls, log aggregation, even containers, even your VMs, right? And that is critically important when we talk about a hybrid cloud model, right? If you're deploying everywhere, you cannot be concerned with all these non-functional details. These are technical details that are required to run something enterprise grade, but no one's a hero for it. Your end user doesn't care. Your end user just cares about the UX. Your end user just wants, click a button, go do something for me, right? And so if I apply this to our ecosystem, that definition of business results over technical detail, I'll bring up what I call, Chuck Swoboda trademark here, the DevOps wedding cake. And what that is a payload, which was Docker. We run Docker containers, which are really fungible and portable across any type of rel-based ecosystem, whether it be OpenStack, AWS, Azure, Google Cloud, VMware, bare metal, doesn't matter. Orchestrated by what probably my favorite thing is in the planet, even more so than OpenShift, although don't tell Red Hat that. Oh, great, I'm being recorded. Kubernetes, which is a orchestration tier developed by Google in-house, open source to the community, and given to all of us. It is an awesome ecosystem. It is the best way to run and manage containers. And I'm so excited to be a part of it. 1-year anniversary is coming up here in a month, which is great. So right on top of this is OpenShift, and that is our Red Hat's DevOps platform, the platform that enables DevOps. And if you apply that definition of DevOps to this wedding cake, you focus on the business results by working only with OpenShift that abstracts away Kubernetes and Docker and everything beneath it from a developer and an operator experience. And what that looks like, what OpenShift does, is it glues together a ton of really awesome open source projects. Things like, again, Kubernetes and Docker, etcd, Elasticsearch, FluentD, Kibana, Heapster, Hawkler. I could go on and on and on and on and on and on. And package it up as enterprise-grade safe bits. And that's what we're going to be talking about, the enterprise-grade version of our software. Now, unfortunately, when we created these slides, that was before the big announcement of OpenShift Local, OpenShift Container Platform, and OpenShift Lab. We still have dedicated, we still have online, but enterprise is kind of split out even further. So I just got to put this little asterisk here because you heard something different at Paul's keynote, which I'm glad we're kind of following, although there's a lot to live up to. Big shoes. And so what OpenShift provides, though, so I talk about, what are these, or how you can just focus on business results. And that's because what OpenShift does is provide a lot of awesome critical features, like self-service, the ability for your developers to say, hey, here's my app code, go run it for me. I don't care how it gets done, just do it, right? Multi-language, so it supports everything that can run in a Docker container, run on Linux for the most part. In fact, we even have a solutions architect in the Fed team where a customer asks him, hey, can you run some COBOL for me in a container and throw it up on OpenShift? He's like, why not? He's a bigger geek than I am, and he did it. And I'm like, whoa, okay, that's the best use case, but go ahead. It automates out a ton of the manual minutia that no one really likes to do. Allows teams to collaborate, so working together, isolated or together, right? No noisy neighbors. It enables you to work very fast. There's no, high priest of codes anymore, right? Everybody has to collaborate. It's standards-based, which is twofold. Standards-based being one that we have galvanized around open source standards in the community, like Docker and Kubernetes and etcd, et cetera. And also that as an operator, you declare standards in OpenShift for how your cluster runs, how your apps run, how your apps are developed, how your apps get out and are actually useful to the end users. And then OpenShift governs that, guarantees that it runs in a certain way. I think if you saw in Paul's, or so it was Burb's up on stage, where he was, SSHing into his particular container, and which is great because a lot of folks want to do that for certain reasons. But guess what? If you try to make some sort of change in there, as he said, as soon as that container dies and another fresh one comes up, anything you did in there changed. So OpenShift is governing those standards that are being, or those policy and standards that are being issued by your operators. Web scale runs large mission-critical workloads. Enough said on that one. Open source. Unlike other platforms of service that are out there, every bit is open source, top to bottom, and which is great because that is community-powered innovation, right, at its finest. It's a true meritocracy, which means the features that you see and grow and know to love will evolve by the momentum of the community. And you cannot get that in open core. You cannot get that in proprietary. It is a meritocracy of vendors, us, Google, even IBM is hacking away at this, and users, you, and ISVs, to bring the best features out. And then finally, enterprise grade. So again, that's what Red Hat does. We take open source bits, package them, test the heck out of them, make sure they're safe, and deliver it to you, and provide support top to bottom. And that support includes everything that's in OpenShift. That support includes support for the Docker container, for Kubernetes, for etcd, and everything else. So as I like to say, we are the one throat to choke, or if we're having a real good day when we impress you, one person to hug. So with that, I'm going to turn it back over to Chris on why hybrid cloud matters to you and us.
Sure. Cool. Thanks, Chuck. So I promise not to provide too many marketing slides here. We want to get into the meat of things. But I've always found this slide in particular very interesting because it kind of validates what we're doing from the outside. Public cloud, specifically two of the larger ones out there, as you can see here, 75% of the addressable market by the end of 2017. I mean, how many of you in here are running something on a public cloud today? Fair warning, in my presentations, you're going to get a lot of this, so have your arms and sockets loosened up. So, it's happening, right? And that's why we're investing in it as well. I heard Paul say that the cloud's built on, open source, and that's true. But now, how do you consume things, and how can you consume them consistently? This is another, kind of thing that's going on. It's driven by these different business initiatives that then map to these technology initiatives. I'll guarantee you don't have to raise your hands this time. Everyone in here is doing something with cloud, something with DevOps, something with microservices, or something with containers. Probably all of them, right? As Chuck mentioned, they're kind of nebulous, though. What does it actually mean? What is it actually there? It's a new architecture for modern apps. It's a new operating model. Different pieces and all of these things in place. And so, you'd think, well, can I just pick one, right? We looked at that as well. Could we go all in with a particular hardware vendor, right? I can remember in the early days of Linux, we maybe tried to get really performant on one specific hardware vendor, and we found out, hey, that's not enabling choice. That's not what the customers are asking us for. And so, when you think about one cloud can't deliver everything, these are just some of the considerations that you have to, right? I mean, really the public clouds in particular, especially coming from an infrastructure standpoint, they're kind of next generation OEMs, right? They're the next generation of server, but it's kind of server plus plus because you have all these additional services and things that you have to integrate with and work with as you move along. And so that gets to, why does Red Hat matter in this world? If you saw the demo today, and I hope all of you had the chance to see it, and if you didn't, I really encourage you to go back and look. It matters to us because we're finally at a point where we have all the pieces to help you get there, right? It's essentially everything. It's all based on Red Hat Enterprise Linux. We have OpenShift to drive the DevOps. We have CloudForms and Ansible, as you saw, to really handle that management. And we're capable of doing that regardless of the environment, right? And we want to do that with the architecture by creating the abstraction layer, right? We want to make it easy for you to just consume what's there and not really have to think deeply about it. So I'm going to spend a little time, now we're getting into the technical portion of the presentation. We'll go a little deep, not too deep. But as I mentioned, it all starts with Red Hat Enterprise Linux, right? When you look at the bottom, whether you run it physical, virtual, private cloud, public cloud, wherever Red Hat Enterprise Linux is supported, OpenShift is supported. Think about that, right? So if you run VMware, that's a supported hypervisor, right? You go to Microsoft Azure, that's a supported public cloud. Wherever you can install Red Hat Enterprise Linux, you can run and use OpenShift. And so once we have that, we have where the applications run. Those are called nodes, if you look in the middle of the picture here. They're based on RHEL, instances, including RHEL Atomic, which is our optimized version of RHEL, just for containers. Now, inside of these nodes where the applications run, there is a concept you'll have to become familiar with in the OpenShift world that we kind of use from Kubernetes called a pod. Right? And what a pod is it allows you to run one or more containers and share resources, right, within that. But you got to think of the pod as your atomic unit. It's not really the container, it's the pod. That's what is managed and controlled by Kubernetes. Now, the historical reasons behind that were, what if the spec for the container changed? Then you'd have to redo your whole platform, right? Because a lot of this work started before the Open Container Initiative. You guys have heard of the Open Container Initiative. It's Docker, us, Microsoft, a lot of the guys in the industry to ensure that this container spec stayed the same. But by having this abstraction, though, we can do some really interesting things. Then we have what's called, the OpenShift master, which, controls the API server. It's where state is managed within the environment, and we know where everything goes. Now, a lot of the pieces that we had to add to make the master and the nodes talk together, when the project first started, the project in this case being Kubernetes, it ran on Google Compute Cloud. Well, not everyone has Google Compute Cloud in their data center, right? So we spent a lot of time creating a service layer that is the communication, from the master to all the different nodes. Today's ours is based on Open vSwitch. But if any of you are using Nuage or Juniper's Open Contrail or if you're using Cisco with their contiv, any of those SDNs you can actually use as well, because it's a completely pluggable layer. We also spent a lot of time, as we also saw in the demo, adding persistence. You know, the whole Mode 2 movement and 12-factor, it's a really awesome kind of thing that's happening. But we've got customers, you know, there was one in particular. I've got 7,000 custom applications. I can move maybe 3 of them to be stateless, right? But I want containers. So how can I get that, and how can I put it together in one platform? So we spent a lot of time with persistent storage. We also provide a routing layer. You know, once you have everything deployed, the routing layer actually runs on OpenShift as well, right? It's highly fault tolerant using the same technology that's underneath. And then, you know, we have API, CLI, and web UI interaction. Now, taking this a little further, we've got this abstraction. We're able to put it in there. You know, that's the basic architecture. If you want deeper, there's a few other sessions that'll go even deeper on that architecture. But what are the technical considerations, right? Now, these shouldn't be much of a surprise to anyone, you know, here that's done a deployment, especially my operations team that's been here. But it's pretty much the same as you do it on premise, except the advantages, or you could argue the challenges you have to consider when you go to a public cloud are they have their own services with each of these. And so you have to figure out how you want to work in those environments. What we're doing with OpenShift, though, is taking care of that for you, where you do not have to think about that, at least as we continue to evolve. So with that, let's take a typical HA reference architecture, right? First, I got to ask, how many of you have actually tried to deploy OpenShift? Holy cow, really? How many have done anything besides the all-in-one VM? Really? Come on up. No. I bet you didn't deploy it this way, though, right? So, true open source form. This is the secret sauce, right? We announced our developer preview of OpenShift Online, right? The first multi-tenant Docker and Kubernetes-based container platform in the world last week. This is how it runs on the back end, right? We're running it, no surprise probably to folks. We've started with Amazon Web Services because, you know, that's where we had the business relationships available first. But if you think about the flow of this, right? Coming in from what looks to be the Ethernet, but that R is just running into the end there, I promise. The calls, you know, from the API or from the web UI are going into an external load balancer that then goes into a highly available master etcd controller cluster that we've set up, right? Now, then there's an internal load balancer. Remember I said the master talks to the nodes and that's how things are managed and going in there. We actually, to ensure that that communication can always happen from the nodes back to the master, we put yet another load balancer in the middle there, right, to make sure that communication can always be there and be available. Because again, we're running this as a highly fault-tolerant and constantly available software as a service. Then when you move to the left, you know, we've got all the infrastructure pieces that are kind of common across the whole environment. Now, we have an external application load balancer that then front ends our own routing layer, which is also highly available, right? This is the piece today that you actually deploy when you install OpenShift. It's based on HA proxy. There's a cool blog post we just put out where you can now actually do that with Nginx as well. And it be built into the platform itself and pulled in with that. And you span this across everything, and then obviously we've got the storage that goes in there. But the bottom line is, it's architected at multiple layers to be highly available. And we are going through with OpenShift Dedicated and OpenShift Online into learning this for you, the customer, and then turning around and sharing it with you. So you can do this yourself, right? If you don't want to consume it as one of our online services, you're going to be able to take this and do it in your environment and follow the same pattern. So I pulled this. We've got a great operations team who's done the due diligence on all of the clouds and kind of put some of these notes together for you guys. So with AWS, you know, this is more of the, just like you don't store your root password, you know, somewhere on your desktop, These are the considerations you need to take into account, right, with AWS. It's really managing those security groups and handling the access keys, whatever is your standard policy in your environment. With Azure, things are improving. I got some folks here that could probably answer it deeper for you. But, you've got the network considerations, right? Multiple IPs to a single NIC. That's not really available, but that's how we deploy at HA. There's other ways to do it, but we're working closely with Microsoft, right, to get that going. Also, another consideration with all the clouds is the number of attached disks. We talked about persistence, but once you get up to like 30 or 40 mounted disks, that could be a challenge that you have to take into account, and we're working through those as well. Availability sets versus availability zones, right? So availability zones is an AWS concept. However, Azure, the availability sets do some very interesting things for us as well, and so we're looking to come up with the best configuration to use those, because they actually, with some of the things we're doing, especially the internal load balancing that I mentioned, you can get some really nice anti-affinity in policies, right? Everyone's always worried about affinity. Make sure this goes here, but less about make sure it doesn't go there, right? And so the way the availability sets work, we're seeing some really interesting patterns come out there. When you look at GCP, which object store, right? So the plugins are available because obviously with the Kubernetes relationship there are available for all of these, but we're actually traditionally use a lot of block store, but we're looking at object store with GCP just because the performance seems to be a little bit better, and so we want to just keep iterating on that as we move forward. The network load balancer, we've hit something with VM fencing. Any of you know what that is? It's like, hey, something looks bad, so we're going to isolate this guy from the rest of the world, which if you're doing a highly fault-tolerant environment, could be a problem. Unfortunately, we've not seen it too many times, and we're working closely with Google to make sure that we have the right solution to get around that when it does happen. And then with OpenStack, ton of OpenStack sessions here, so I'm not going to spend a lot of time with it. But it is just making sure you've picked the right environment, right? Size it appropriately. Take the most advantage you can of Ceph, right? It's a very powerful storage solution combined with OpenStack. And when you put OpenShift and OpenStack together, you get the best of all worlds, especially running on premise. And so kind of with that, we're trying to get consistency with this abstraction, but all of these clouds are all unique. As Chuck says, everyone's a snowflake. Everyone is special, right? When you put a bunch of snowflakes together, you get nice snow. And we're trying to get to that point. And so instead of just me talking about what we do at Red Hat, what I want to do is hand it back to Chuck, who, by being in the field, helping close some of these deals for us, is going to talk to you about some actual customer deployments that are going on and how they're doing things in this hybrid world. So, Chuck.
Thanks, Chris. To expand on this was... anybody who knows me knows I'm like a man of metaphors and anecdotes and analogies. And this is really funny. I got into a spirited conversation with someone else who's in the community, one of our competitors, and he was driving home the idea of very, very opinionated platforms. And so I say, well, everyone's a special snowflake. And his response is, all snowflakes are made of water, so everything's the same. And then I said, well, water comes in 3 phases. So everything's different, so we have to kind of flex and ensure that we are able to provide a solution that meets their needs. And what I want to show you here is several things I've seen in the field, both in public sector and commercial. Don't worry, if there's customers of mine in here, I'm not naming names. We're dropping them all. But these are all real world. And the first one is what I call a scratch start in terms of moving to the hybrid cloud, right? And that is more or less sanctioned shadow IT, where a group, a project, will go out and buy some credits on AWS or Azure or whatever, and will do completely isolated development, both dev, which is low, or QA, et cetera, and prod. They'll deploy OpenShift, new databases, everything. It's completely net new. And then on-prem, while is running basically everything up to and probably including the kitchen sink. It's business as usual. And then they're managing both. And they might do something like put CloudForms out there and for a single pane of glass view. But what they're doing with OpenShift is completely isolated. And that is where a lot of customers start because it's safe, it's friendly. It's away from everyone else. This whole platform as a service, a containers business sometimes isn't trusted. And that's a great place to start on this journey. And you'll hear me say journey a few times too, because it is. Going to a full hybrid solution is 100% a journey. Don't bite off more you can chew. So the next up, when they're a bit more comfortable with containers and OpenShift, they'll use a cloud service provider to build their low system, right? So they're going to do development out there. So because they can spin up VMs real fast, they can expand with developers need, and it's fairly cheap. But they understand that production, maybe for production data loads, et cetera, they'll move that back on-prem. And this is a little bit of a misconception here in terms of it is OpenShift where we see these guys running on there, but at the same time, some customers will even just develop an OpenShift and take their bits and run it on a traditional VM or a regular app server. Because really, when you're developing new apps, there's nothing specifically tying it to OpenShift, which again is that portability aspect of it. So we've seen that too. And this right here is where they're a bit more comfortable. Again, they're more comfortable with running, so they run on-prem. I say a lot, the second mouse gets the cheese, right? Well, OpenShift is now mature enough, so we're all pretty much that second mouse. But with the organization, this is a big deal. So this is a great step. And this is, again, mostly net new. But then a lot of customers are like, well, I don't want to build a new app. I got all these existing legacy applications that I want to modernize through OpenShift. I want the log aggregation. I want the easy deployment. I want the single pane of glass management, et cetera. So they'll ask us to help and lift and shift their app, which actually OpenShift does such a great job. So I like to say lift and OpenShift. If it runs in Docker container, if it's kubified, it will in fact run. And this is where we see a lot of. And then when we're seeing customers lift and OpenShift, we get a model similar to this. And this is where we're going to run both low and high payloads in cloud and their legacy apps. But what is the thing that's really, really hard to move to the cloud? Databases, right? Services, authentication, monitoring, et cetera. So you'll see a dedicated pipe between the cloud service provider and on-prem, and they will be tying back and running that way. And this is very common. This is probably once that shadow IT, once that pilot gets over, this is where a lot of our customers are today. I would say most of our customers here. I have one customer in this, and I have several other that I've seen that are doing the exact same thing. Very common. Next, we got very hybrid. All right, so this is another one. This is an interesting one here, and there's two customers I've seen do something like this. And that is where they're running workloads oh my gosh, I almost said the cloud service provider, on a CSP for the elasticity, running other workloads on our OpenShift platform, OpenStack platform, whether they be on OpenShift, whether they be in VMs, traditional VMs, et cetera, as well as running atomic host on bare metal in a DMZ, because they don't need the elasticity requirements or anything like that, right? And if anyone knows anything about OpenShift, bare metal is a great way to run OpenShift. You don't have to pay the tax of the hypervisor. You don't have to pay VMware. I will say that. It's not for everyone, but a lot of customers do. In fact, if they can run bare metal, I highly recommend it. And then finally, this is another interesting one that we've seen, and that is HPC development, so high performance computing. Again, remember I said I'm a big fan of Kubernetes, so I'm actually going to talk about this. This is not even OpenShift. This is just straight up Kubernetes, where a customer will take a workload, containerize it, and this is mathematics, scientific community kind of stuff, and we'll run it in a container on Kubernetes pinned to a specific core. So they know basically the performance of this core extrapolates out to the performance of my prod HPC environment, and they'll leverage containerization and Kubernetes for very fast development. And then what they'll do is they'll take that same bits. Remember I say you can take those bits out because they're not nothing really tying to the underlying infra, which is the underlying platform. And then they'll actually push that to HPC and run it in production, which is really, really cool. This is a scientific customer out here. And I'm trying to get them to contribute back to Kubernetes right now, but it's a little taxing. So with that, I gave you a few examples here, and I know there's a plethora of questions on it that we're going to, we have a lot of time to answer. But as a reminder, in terms of the journey you take when you go hybrid cloud, I like to say burgers, not steak. everyone loves, you know, a nice big porterhouse, especially me. But also, I'm a huge fan of a White Castle hamburger. They're tasty. My girlfriend hates it, but you know, that is all you need. They taste great. Start with that. Start with the small bites. Don't bite off more than you can chew, because when you go on this hybrid cloud journey, you're going to have to convince a lot of people that this is the right way to go. And take small nibbles. You hear MVP, minimum viable product, right? And then bite a bit more, bite a bit more, bite a bit more, and then head down to Morton's and you can get the steak. And that's where you go something full hybrid, as we showed before. And with that, you know, lift and shift, lift and OpenShift, just lift the little stuff first. That's all I'm saying, right? Try something small. You don't have to do something crazy. You don't have to worry about it. You don't have to put a GLB in front of everything. And this, oh, these are all, by the way, this information up here is, you know, find out more. You know, OpenShift is very active on Twitter, very active, so are we. The Cloud Native Computing Foundation, which is part, or which is what OpenShift is, I'm sorry, Kubernetes is part of. And there's a Slack Kubernetes channel, join, so you can get even more information, et cetera, et cetera.